Hi, I'm glad to welcome you again to our last lesson. This is lesson number 14 on our topic of energy changes in physical and chemical processes, fuels. This is going to mark our last lesson on this topic. So by the end of this topic, we'll have finished what we need to cover on energy changes. I'm glad for those who have stayed with me. These videos, I've posted them on YouTube. Subscribe. Also press the notification button, that bell sign, so that you get more videos that I'm going to be posting just to help the candidates as you are at home, comfort of your home, still you can attend this lesson. So I'll be doing more topics to add to that. So fuel. So let's say discuss what fuel is. So a fuel is any substance which, when it burns, it produces useful form of energy or useful energy. The energy produced by most fuels is in heat, a form of heat energy, and that fuel can be converted, or that heat energy can be converted from one form to another, as I had explained in the introduction part. For example, the light or the heat energy from the solar can be from the sun, can be converted by the solar panel to electrical energy, and then electrical energy can be converted to light energy, like used in the bulbs, or can be used again, can be converted to heat energy, can be used for cooking and so forth. So to enable us to go through this, I will project the notes on the screen. So let's go through the notes with you about this last part. I'm going to put it on the screen so that we discuss. So those who can, you can pause and also write those notes. Okay, so as I've said, a fuel is a substance that produces useful energy when it undergoes a chemical or nuclear reaction, when it burns, whichever way, nuclear reaction or chemical reaction. Chemical reaction mostly is by combustion. When you burn, it produces useful energy. That's what we call a fuel. So the energy that's produced, as I've said, you can use it directly or can be converted into other form of energy. For example, electrical energy, as I've said, or even light energy and so forth. Now, fuels can be solids, and the examples of solid fuels, we have nuclear fuel, we have coke, coal, charcoal, and wood. So the nuclear fuel, for example, some elements like uranium, particularly uranium-235, is used for nuclear purposes to generate nuclear energy. Then coke, most industries, large industries that require a lot of heating, they use coke, and also coal. Then charcoal is used domestically in some of our homes for cooking. Wood, particularly the rural areas, they use firewood for the purposes of generating heat energy for cooking and so forth. We also have fuels that are in liquid form. Examples of the liquid fuels include petrol, kerosene, diesel. Now petrol, diesel, mostly they are used in engines, in vehicles. Small vehicles, they use petrol. Then the larger ones, the trucks, they use diesel. Kerosene is a fuel for aeroplane, and it is also used domestically for cooking and lighting. And then fuels can also be in gaseous form. So gases, fuel include the natural gas, water gas, and liquid petroleum gas. So the natural gas majorly is methane. Water gas is a mixture of water vapor or steam and carbon dioxide. The mixture of the two burns at a very high temperature, liberating a lot of heat energy, which can be used for different purposes. So generally, in most cases, not all the heat energy that is liberated by combustion process is utilized. A lot of it is usually lost to the environment. Now let's consider the next part, that is the heating values. What is heating values of fuels? So heating value refers to the amount of heat energy given out when a unit mass or a unit volume of a fuel is completely burned in oxygen. And this heating value is usually given or expressed in kilograms, in kilojoules per gram, joules or kilojoules per gram. For example, ethanol has an enthalpy of combustion of negative 1360 kilojoules per gram. That means when you burn 1 gram of ethanol, it gives you the heat energy, which is 1360. So the negative sign is just to mean that heat energy is given out. So by dividing this value by the formula mass of ethanol, which is 46 grams, then the heating value of ethanol will be 30 kilojoules per gram. We can use this then to at least to explain why some fuels are better than others. Like, for example, given a choice to cook using a gas, if you have a gas cooker, and charcoal, most will prefer to use a gas cooker and not charcoal, not just because it is tedious to light the charcoal stove and so forth, but even in terms of heating, the gas will cook faster than the charcoal. So let's see what contributes to that. So the heating value can help us to at least determine which fuel will give us more heat energy. Hence, we can now decide which fuel to use when, or then next we are going to look at the factors to consider when choosing fuel, and the heating value is going to be a crucial point to consider. So to determine the heating value, so heating value will be determined as the molar heat of combustion. So you take the molar heat of combustion of a substance, then you divide by the relative formula mass. So there you have a table of the heating values of some of the common fuel. For example, charcoal has a heating value of 33, coal 29, wood 17, ethanol has 30. And then among the liquid fuel, we also have fuel oil 45 and paraffin 48. And then gaseous fuel, we have methane, which is the natural gas, propane and butane. So if you look at that, of all the fuels that we have there on our table there, the natural gas, which is methane, has the highest heating value of 55 kilojoules per gram. And that explains why the gas cooker cooks faster than any of those other fuels listed there. So, and that's why it is the most preferred fuel even at home, particularly homes, domestic use for cooking. Now, let's consider factors that will influence your choice of a fuel. Which fuel you will pick on, it will depend on a number of factors. As I've said, the most important one mostly is the heating value, but there are other factors. So let's see other factors, or the factors that affect the choice of a fuel. So one of the factors, as I've said, is the heating value. You will choose a fuel that will give you a lot of heat, definitely. Another factor to consider is cost. You might want, for example, to use a gas cooker, but maybe financially you are not able to afford to buy the gas cylinder and even the refueling and so forth. Like particularly some remote areas there, you might even have the money, but there is no place to refuel your gas cylinder. So you might opt to use another source of fuel, another source of heat, like for example, charcoal or firewood, particularly in the rural areas, because the gas is not there, it is not available. So we have the cost, you are not able. The other factor will be availability. You might have the money, you have the money, but it is not available. So another factor will be availability. That is number 4 there on our screen. Also, the ease and the rate of combustion. You will wish to use the fuel that burns at a moderate rate, not very fast, explosively. For example, you cannot use petrol for cooking, because if you do that, you ignite, it will explode. So you will not be able to use such a fuel because it will cause the house to catch fire. You might even also burn yourself and even die, destroy a lot of damage. So you might prefer, like for example, use kerosene because it burns moderately, even though the heating value will be much lower, but it burns moderately. So importantly, you have to consider the ease and the rate of combustion, very crucial. There are fuels, they cannot be used for cooking because they burn, liberating too much heat, and they also burn very explosively. Then the ease of transportation. You might need to use a particular fuel, but the location maybe from where it is to where you want to use might be very far, might not be easy to transport. So you might opt to use a different fuel from your fuel of choice, and the problem is because of the transportation issues or problems. Another factor is the environmental effects. If that fuel has an effect on the environment, then you might have to reconsider it. Use the fuels that are environmental friendly where possible. Then lastly, the factor to consider is the ease of storage. Now there are some fuel that we use domestically, for example, wood and charcoal. Why do we use this most often? Why is it that in most homestays you find they use wood and charcoal? These are the reasons. One is because they are cheap, so most of people can afford, particularly in the remote areas, rural areas. They are cheap. People plant trees, so it is easy to get the firewood, and even some of the trees converted to charcoal. They are readily available. So I've said some people have planted trees, a lot of them, the homestead, along their farms, so it's easily to fall a tree, get enough firewood. They can easily be transported. They burn. When they burn, they do not produce poisonous products, and they also burn slowly. Their mode of burning is slow. There's another fuel we call methylhydrazine, which is used as a rocket fuel to propel the rocket, and it is used so because it burns very rapidly, producing large amounts of gases, which in turn create huge thrusts as they escape. It also has very high heating value, so it will produce a lot of heat energy, sufficient enough to give the lift off for the rocket, and then it ignites very easily. There are some precautions that we have to take when you are using different fuels. So let's look at the precautions to take when using fuels. So these are the precautions one should take while handling fuels. For example, charcoal stoves should be operated in well-ventilated rooms to avoid poisoning by carbon dioxide. Vehicle engines should not be left running in closed garages to avoid poisoning by carbon dioxide gas. The gas cylinders should be stored in well-ventilated rooms far from the heat sources, and only certified gas cylinders should be used for gas transportation. Fuel storage facilities should be located away from populated areas. Then people should keep off from spilled fuel from tankers. As we have seen, there are several occasions where people ran to fetch fuel from tankers which had accidents, spilling oil. Then people went to fetch, and then accidentally they caught fire, and many people died as a result of that. So should there be an accident where there is a fuel tank, maybe had an accident and then the fuel is leaking out, please keep away from it. Try to fetch that oil. It might be the last thing you ever do in your life, and even if you survive, you might be disabled the rest of your life, so you might find your life will change drastically. You'll never be the same again. So there's no point in so doing. So some of those fuel are going to fetch, maybe it is petrol, where are you going to use it, and maybe you don't have a vehicle. So if I find most of the people who rush to fix such oil, they don't even have the engines which they are going to use, and then end up losing your life or part of your body. It's not necessary. So keep off from spilled fuel from tankers. It is also important to note that improper handling of fuel can result to death and destruction of property. So each fuel should be handled with the necessary care and precaution. So we have to be very careful when we are dealing with the fuels and handling them. Let us now consider the environmental effects of fuel on the effects of fuel on the environment. One is that the fossil fuels such as coal and petroleum contain carbon, nitrogen, and sulfur compounds, which on burning produce gases such as nitrogen dioxide, sulfur oxide, sulfur 6 oxide, and even carbon 2 oxide, which are poisonous and they have negative effects on the environment. For instance, sulfur and nitrogen oxides dissolve in water to produce acid rain. Now, acid rain has adverse effects on stone buildings, which it wears down or wears out the stone buildings and statues. It acidifies lakes, leading to death of the aquatic animals, corrodes iron sheets, iron gates, and other metallic structures. It also leaches the nutrients from plant. From the soil. This leads to the the plants having less nutrients from the soil, which leads to their death and also poor agricultural soils and yields. Carbon 4 oxide and other unburned hydrocarbons from fuels contribute to global warming, which cause polar ice to melt, thus leading to increase in ocean levels. Now, this threatens the low-lying land. We have seen some geographical disasters, for example, the tsunamis and such, water from the seas, the oceans, overwhelming some islands, sweeping property, people, animals, destroying lives and property. And causes is some of those will be the rising sea levels because of the melting of ice due to global warming. Also, tetraethyl lead, which is added to petrol to prevent engine knock, contains sulfur, which contains compounds which are poisonous. For example, the lead oxides, which have been associated with nervous disorders and learning disabilities in children. Though nowadays most of the fuel is unleaded because of this problem of lead poisoning. Now, there are measures that we can take to reduce pollution by the fuel. For example, designing vehicles which use solar energy or electrical energy, which are pollution free, what we call green energy. Also, fitting catalytic converters for the exhaust systems, and this is particularly for industries or factories. These catalytic converters convert nitrogen oxide to harmless nitrogen, carbon, and also carbon 2 oxide to non-toxic carbon 4 oxide, and burned hydrocarbons to water and carbon 4 oxide. Also, designing engines which use unleaded petrol. Like nowadays we have a number of vehicles that their engines use unleaded oil or unleaded petrol. Then electrically controlling the quantity of air mixed with the fuel to ensure that more complete combustion. Also, adding fuels which contain oxygen in their molecule to petrol, e.g. methanol and ethanol, may be added to petrol. These fuels reduce the quantities of carbon 2 oxide and unburned hydrocarbons emitted. We can also encourage other means of transport, such as use of bicycles, electrical trains, even walking where necessary. And finally, we can also use the use of heat exchangers. This is because the uncontrolled heat can be a pollutant. So it is necessary for industries to use the technology, the method we call the heat exchangers, the heat exchangers, this process ensures that the temperatures at which the process are taking place is maintained within a range that favors best yield. Then just a point to note that heat exchangers are usually constructed in such a way that there is counterflow of the substances, so that the cooling of some materials by the hot ones will minimize the heat that will otherwise gone to waste, and by so doing, effectiveness in the industry and also reduction in environmental pollution. And that marks the end of our topic, energy changes in chemical and physical processes. I was your teacher Juma. You're most welcome. Please subscribe, press the notification bell to get more videos and then other topics that I'll be posting soon. Thank you. God bless you. Stay safe and work hard. All the best.